Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part B. This is Lesson 2, and we're going to focus on numbers 1 through 6. I'm going to show you exactly what you need to be able to do on these. Just like we're having a little bit of trouble making this a lot harder than it has to be. So in this situation, we are given some information, and we're going to use that information to either prove or disprove that these two triangles are similar. So now if I'm looking at this information, here's what I notice. I notice that in this triangle, I've got 10 and 15, and in this triangle, I have 12 and 18. Now, if I'm going to make comparisons, then I'm going to have to compare sides that are corresponding to each other. So big side to big side, small side to small side. So over here, I'm going to have to compare 15 to 18 because they're the largest sides of the triangles, according to the diagram. I'm going to also have to compare 10 to 12. I can't mix those up. So make sure that as you're looking, make sure you're comparing the correct sides. So once I compare those, I'm going to set up ratios and see if I get the exact same ratio of sides. So for example, I'm going to do UW over WY, and that's going to be 10 over 12. And that reduces to 5, 6. Now the other set must also reduce to 5, 6. So that would be VW over WX, and that's 15 over 18. If I divide these by 3, I get 5 over 6. So I have two corresponding sides. So now, since the ratios are the same, these are similar. Now we've got three methods to prove that triangles are similar. We've got side angle, we've got angle, angle. We've got side, angle, side. And we've got side, side, side. Now a lot of people are trying to go ahead and say, well, UV and XY must also be proportional, but we don't know because we don't have numbers. We can only say what we see and what we can prove. So what else can I prove here? Well, I've got two intersecting triangles. The intersecting triangles have segments that make opposite rays, and that gives me vertical angles. So right here, I have a pair of vertical angles that I can say are congruent. And so I also have angle, UWV, has to be congruent to angle, YWX, and that's vertical angles are congruent. Now, once I have this, I have a side, an angle, and a side. So now I can make the statement that triangle UWV is similar. Make sure you use a similar sign, not the congruent sign, to triangle YWX by side, angle, side similarity. Now, all of this must be in your statements. You must make these statements about the sides, showing that they are proportional. You must make the statement about the angles, and then you must make the congruent statement right here. So that's all you got to do, just that, then you're done. Once you have all that information there, I can look at it, you're done. All right, so let's take a look at another example. So now what do I know in this diagram? Well, the only thing I know is that these two segments are parallel. So I can't make any side statements. So right away, I know the only way I can show these triangles are similar is by angle, angle similarity. That's the only thing I can do. So how do I do that? Well, I've learned back in part A, when we talked about parallel lines, that we've got two sets of congruent angles. So those two angles must be congruent. Now, why must they be congruent? So we got UVW, and that's angle, is congruent to angle YXW, and that's by alternate interior angles. And you can say that, that's fine, I'll accept that. So now what's the other set of angles that are congruent? Well, it's these two. And they're congruent because of the same reason. So I've got angle V, U, W is congruent to angle X, Y, W, same reason, by alternate interior angles. I have two angles, so now I can state that the triangles are congruent. Now I could have also made a statement about those angles, but I only need two, and I'm kind of showing you a quick way to do it. So if you make that statement about those angles with one of these others, that's also an acceptable way to show that these are similar. So now I got to make my triangle statement. So I've got triangle. And you got to make sure you label them in the correct order. So VWU is similar to triangle XWY by angle, angle. I'm thinking the word and not writing the symbol, similarity. So again, make both of these angle statements and then make the triangle similarity statement. You're done. All right, let's take a look at these. Only thing I know here is that I've got a pair of right angles, and that's marked right here. So I've already got one angle that is congruent. I have no sides, so again, the only way to show that these are similar is using angle similarity because I have no side markings. So I've got angle V U W is congruent to angle X Y W, and that's all right angles are congruent. Simple statement right there. All right. What other angle can I make? Well, I got these angles that intersect right here. Again, the vertical angles, they are congruent. So I've got angle VWU is congruent to angle XWY, and that's by vertical angles. And so again, I've got my two angles. So I've done my job in showing that these are similar. So I've got triangle VUW is similar to triangle XYW by angle, angle similarity. So again, both of the statements and then the triangle similarity statement, and you're done. All right. So now this one, again, I'm going to have to set up ratios for corresponding sides and see if I get the same ratio. If I don't get the same ratio, then I know they're not similar. So I'm matching up the smallest to smallest. So the smallest here is 9. The smallest over here is 6. So I've got 9 over 6, which will reduce to 3/2. Okay, the next smallest would be 12. So next smallest here is 8. 12 over 8, divide by 4 to get 3 over 2. So far, so good. I have to check all three. 18 over 12, reduced by 6 to 3 over 2. So look at that. All three of these make the same ratio. Now, if one of these is not the same, then I can make a statement that these are not similar. But since I have all three are the same, I can say that triangle ABC is similar to triangle DEF by side, side, side similarity. So if one of those is not the same, then you make a statement that these are not similar and state why, because the ratios are not the same. All right, one more. So now this is a lot like one you see in the lesson. So again, all we know here is that 14 and 28 are given numbers. So now we had a little lesson in the last course that said if, and I need to add something here. I'm going to add this right here because I forgot to add it in my picture. Two things have to be true. First of all, the side is parallel to the side. So this is parallel to this, and it's half. That makes this a mid segment. So since this is a mid segment, then here's what I know. I know that this is going to be proportional to this, and this is going to be proportional to this. There's lots of things that you'd have to make to say it, but it's going to eventually be true because this is a mid segment. So I can make the statement that AD over AC is going to equal AE over AB. Now, once I have those are two sides that are proportional to each other. All I need now is an angle, so I can prove this. And I could do this with side, but I want to show you the angle because you're going to need the angle in the one that you're doing in the lesson. I've got an angle that both of these triangles share right here. So I'll also have angle DAE is congruent to triangle, not triangle, I'm getting ahead of myself, to angle CAB, and that's reflexive property. You have to make sure you say Y on this one, and you're going to go mid-segment theorem right here. And this is by reflexive property. And now that I have two sides and an angle, I've got triangle BAE is similar to triangle CAB by side angle side. All right. So I hope this helps you with numbers 1 through 6 in lesson 2. If you still struggle with these, please set up an appointment for a help session, but definitely let me know in a teacher message.